بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Math grade 6. We are on chapter 12, lesson 4. Today we want to learn shape of data distributions. Shape of data distributions. See with me now this video.
ايش يخليك تحس كده؟ Chapter 12, Lesson 4, Shape of Data Distributions. You will be able to describe a data distribution by its center, spread, and overall shape. Data that are evenly distributed between the left side and the right side have a symmetric distribution. The distribution shown has a cluster of several data values within the interval 10 to 12. So here, between 10 and 12, most of the data is clustered. The gaps 9 and 13 have no data values. So there's a gap between 8 and 10 and a gap between 12 and 14. The value 10 is a peak because it is the most frequently occurring value. Describe the shape of each distribution. The line plot above shows temperature in degrees Fahrenheit in a city over several days. So if I were to draw a vertical line anywhere on this graph, it would not be the same between the left and the right. So I would say that this is not symmetric. So let's write that in. This would be not symmetric. Clusters. Well, if we take a look here, we have some clusters here. Let me get the highlighter. We have a cluster here, and we have a cluster here. Okay, that includes all of this data. Okay, so I can say that both are clusters. So let's jot that down as well. So the clusters are from 16 to 18 and 22 to 25. There are some clusters. Gap, it has a gap right here. Okay, so our gap is from 19 to 21. Outliers, you would see outliers way off to one side or the other. And since I have nothing that appears that way, there's no need to go through all the calculations. So I would say there are none. And the peak, the highest point here, is 22. The box plot shows the number of visitors to a gift shop in 1 month. Because it's a box plot, you cannot identify gaps, peaks, or clusters. Okay, now symmetry, I would definitely say it's symmetric. So I can draw a line, that's a little thick. I can draw a line right down the center, and it's the same on both sides. So I would say that this does have symmetry. So this is symmetric. And again, outliers on a box plot generally would be way out there, stars or asterisks on either end. And since I don't see any and it's relatively, and because it's symmetric actually, we would say there are no outliers. Use clusters, gaps, peaks, outliers, and symmetry to describe the shape of the distribution below. Okay, if I were to draw a vertical line anywhere on here, it would not be the same on either side. So this is not symmetric. Cluster. Honestly, I can see a cluster in this area. So I would say the cluster is between, looks like minutes and seconds, so I would just say 0, 0, 1 to 7:30. And this is minutes. Okay, and gaps, I don't see any gaps, so no gaps. There are also no outliers. If there were outliers in this histogram, you would see a big gap and then a bar way off to either the right or the left, and I do not see that. And the peak is within this interval, so from 0 minutes 1 second to 2 minutes 30 seconds. Now, we can use this flowchart to decide which measures of center and spread are most appropriate to describe a data distribution. If there is an outlier, the distribution is not symmetric, usually not symmetric. So, is it symmetric? If it is symmetric, we will use the mean as the measure of center and the mean absolute deviation as the measure of variation. If it is not symmetric, we will use the median and the interquartile range. So we don't have to find everything. We only have to find two things, one measure of center and one measure of variation. So the line plot shows the number of states visited by students in class. Choose the appropriate measure to describe the center and spread of the distribution. Justify your response based on the shape of the distribution. Write a few sentences describing the center and the spread of the distribution using the appropriate measure. So the first thing we need to figure out is it symmetric? If I draw a vertical line anywhere on this graph, it will not be the same. So this is not symmetric. So let's write that down. Data is not symmetric. Therefore, we will use let's go back to our flowchart. Not symmetric, we're going to use the median and interquartile range to describe the data. Therefore, the median and IQR best describe the data, or best describe it. Okay, so that's what I'm using and my justification for it. That answers right here. Justify your response based on the shape of the distribution. We chose our appropriate measure. Okay, that takes care of that chunk. Now write a few sentences describing the center and spread of the distribution. Well, we have to actually find them. So let's list our data from least to greatest. 10, 10, 10, 11, 11, 5 times, 12 is 6 times, 13, 14, and 19. There's 3, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 data. 2, 4, 6, 8, 10, 12, 13, 14, 15, 16, 17, 18, 19. Okay, so let's go ahead and find the median and interquartile range. Well, in order to find the median and the interquartile range for that matter, we should probably find our minimum and maximum as well. So the min is 10. The max is 19. Let's go ahead and find the median. So the median is 12. And our interquartile range, we need to find our quartiles. So this is quartile 1. And let's do the same to find quartile 3. There we go. So to find the IQR, we need to take our quartile 3 minus our quartile 1, and we get an IQR of 2. Okay, The median is 12 states. The IQR is 2 states. Okay. And now let's describe it here. The data are centered around a median, well, we don't have to say that, are centered around 12 states. The spread of the data around the center is 2 states. Okay. Letter B. Describe the center and spread of the distribution. Justify your response based on the shape of the distribution, then describe the center and spread. So if I were to draw a vertical line, I could actually draw it right here, and it would be the same on both sides. So I would say the data is symmetric. Since the data is symmetric, I'm going to use the mean and the mean absolute deviation. So the data is symmetric, therefore, the mean and the mean absolute deviation best describe it. Now let's find the mean and the mean absolute deviation. Well, to find the mean, we need to add all of these numbers up and divide by the total amount of numbers. So let's grab a calculator and add them up. 25 plus 26 plus 26 plus 27 plus 27 plus 27 plus 28 plus 28 plus 28 plus 28. 29 4 times plus 34 times plus 31 3 times, then 32 32. Oops. Okay, so plus 31, I lost a little bit on my calculator here. 3 times plus 32 plus 32 plus 33. And then we are going to take that amount and let's see, let's divide it by, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 14, 18, 19, 20, 21, 22, 23, 24. So we had a sum of 696 for our mean. Our mean equals 696 divided by that 24 gives us 29 as the mean. Now, once we have the mean, we need to find the mean absolute deviation. So to find the mean absolute deviation, oops. Okay. We are going to take the absolute value of every data subtracted from the mean. And remember, put your largest number first. So 29 minus 25 absolute value. And I'm going to go ahead and write them all first. You know what? Actually, there's an easier way we can do this. Let me show you here. Because we have a line plot, there's a way we can do this with not so much writing. We know that the mean is 29. So 29 right here is the mean. I'm going to draw a line through that. That's the mean. So you want to find out how far away each data value is from the mean. Well, the x's that are on 29 are right on the mean, and there are 4 x's. So I'm going to say these are all 0 spots away from the mean. Let's go to the left first. 28 is 1 away from the mean, and there are 4 of them. So 1, 1, 1, 1. 27 is 2 spots away from the mean, and there are 3 of them. 26 is 3 spots away from the mean, and there are 2 of them. And 25 is 4 spots away, and there's only 1. Now let's go to the right side. The mean again is 29. 30 is just 1 away from 29, and I have 4 30s. So 1, 2, 3, 4. 31 is 2 spots away from 29, and there are 3 of them. 2, 2, 2. 32 is 1, 2, 3 away from 29. And 33 is 4 away from 29. Now let's find the average of these numbers. So let's add them in the calculator. 4 plus 3 plus 3 plus 2 plus 2 plus 2 plus 1 plus 1 plus 1 plus 1 plus 0 plus 0 plus 0 plus 0 plus 1 plus 1 plus 1 plus 1 plus 2 plus 2 plus 2 plus 3 plus 3 plus 4 gives us 40. And again, divide that by the 24 numbers that we are 24 numbers that we have. So mean absolute deviation, we get 40 divided by 24, and let's round to the nearest tenths place. We get 1.7. Okay. So let's now describe it. We have our mean and our mean absolute deviation written out, so we can say the spread of the data around the center. Oh, hang on. The data, forgot about the mean. The data are centered around the mean of 29 years, period. And the spread of the data around the mean is about 1.7 years, which is the mean absolute deviation.
So today we want to learn how to classify the shape of data distributions. What's the meaning of distribution? The distribution of a set of data shows the arrangement of data values. This is the meaning of distribution. What's the meaning of symmetry? The left side of the distribution looks like the right side. What's the meaning of cluster? Data that are grouped closely together. What's the meaning of gap? The numbers that have no data value. What's the meaning of the peak? The most frequently occurring values of mod. And here we have two cases. If the data distribution symmetric, use the mean to describe the center, then use the mean absolute deviation, MAD, to describe the spread. So the second case, when we have the data distribution not symmetric, here find the median to describe the center, then find interquartile range, IQR, to describe the spread. In our lesson today, we want to learn what's the meaning of distribution and how to know if the shape symmetry or not, and how to know if I have cluster data or not, and what's the meaning of gap, and what's the meaning of the peak. And we have the outlier. You know this idea from the last lessons. And if the shape symmetric, just find the mean and the mean absolute deviation. And if the shape not symmetric, just find the median and the interquartile range. To know these ideas, listen to this example. Listen to this example. The question here, the box plot shows the math test scores describe the shape of the distribution. So I want to describe. When you want to describe the shape, this is the shape. As you have here, we have box plot. When you want to describe the first step, determine if the shape symmetric or not. Then find the gaps if you have, find the outliers if you have, find the cluster if you have, and find the peak if you have. But as you see here, we have data, but the all data inside the number line, Here you have 60, here you have 65, 70, 75, 80, 85, 90, 95, 90. No gaps. What's the meaning of gap? Gap means each data have value. Each number inside data have a value. Each number inside data have a value. So here we have value 60, 65. No number without value. All numbers have a value. So here no gaps. Now each number repeated just one time. Here 60 just one time, etc. So means no peak. The meaning of the peak, the same meaning of the mode, the most often, frequently. So each number here just repeated one times, so no peak. Cluster means some data grouped near together or close together. But here we have each number in the place on the line plot, on the box plot. So no data grouped together, So I can write here no clusters, and no outliers. Why? Because the value of the numbers here close to the same value of the other numbers. So no big distance between one value and the all values. So here no outliers. As you see here, if I draw here line, in the middle line, the right numbers as the same of the left numbers means here we have symmetric shape. I will repeat here. If I draw here line on the middle, see the right data like the left data, the distance from here to here like the distance from here to here. So this is symmetric shape. When you have symmetric shape, so here the shape of the distribution is symmetric. When you have symmetric shape, just find the mean and find the mean absolute deviation. How to find the mean? Add the all data, divide the number. Here we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So divide by 9. Will be 80. This is the mean. How to find the mean absolute deviation? Take each data here from here, each number here, minus the mean in absolute value. For example, 60 minus 80 will be minus 20. In absolute value will be what? Will be 20. 65 minus 80 in absolute value will be minus 15. In absolute value will be 15. 70 minus 80 will be minus 10. In absolute value will be 10. And here 75 minus 80 will be 5. In absolute will be minus 5. In absolute value will be 5. 80 minus 80, 0. And here etc. the like idea. So I can write MAD. What the meaning of MAD? Mean absolute deviation. So this is the data here, 20, 15, 10, 5, 0, etc. divide the number. We have 9 numbers here. Approximately here will be 11. So now I have the mean 80, and I have the MAD will be 11. So I can write the data are centered around the mean, around 80 states. And the spread of the data around the center is about 11, states. In the second example here, the line plot shows the number of hours several students spent on the internet during the week. Look to the sheet. Here we have line plot. This is the data 0, 1, 2, 3, 4, 5, 6, 7, 20. As you see here, if I draw line on the middle here, for example, the data on the right different than the data on the left. So the shape here not symmetric. Then 4 here doesn't has value, 5 doesn't has value. So we have gap between 4 and 5. So there is gap from 4 to 5. This is the meaning of gap. No value. Here we have values, here we have value, here we have values, here we don't have. So here we have gap between 4 and 5. And look here, between 6 and 7, we have some data grouped close together. And here between 1 and 3, we have some data grouped close together here. So here we have cluster, and here we have cluster. So I can write here, there are cluster from 1 to 3, and from 6 to 7, and from 6 to 7. This is the meaning of cluster. And as you see here, we have big distance between this value and the all values. So this is the meaning of outlier. So the outlier here is what? Is 20. The outlier here is what? Is 20. Here we have 1 value, here we have 3 values, here we have 1, here we have 2, here we have 1, here we have 4. This is the more repeated numbers, the more repeated value, the most often frequently. So the peak, the same idea of the mode, So the peak here will be what? Will be 1, because 1 has the most often frequently. Here we have 4, here just 1, here 2, here 1, here 3, here 1. So here the most often frequently. So the peak here will be what? Will be 1. And as you see here, the shape not symmetric. If the shape not symmetric, what we do here? Just find the median and the interquartile range. How to find the median? Take the data and rearrange the data from small number to the big number. Then as you see here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 is even. So the median, the two numbers on the middle. To find the median, find the mean between 3 and 3. 3 plus 3 divided by 2 will be 3. So the median here will be 3. How to find the first quartile? Here we have the first set. The number on the middle will be the first quartile. So Q1 will be 1. How to find the third quartile? The second set here, the number on the middle will be 7. So the third quartile will be 7. How to find the interquartile range? Q3 minus Q1. 7 minus 1 will be 6. So the median determines the center of distribution, and the interquartile range determines the spread. So I can write the data is centered around 3 states, and the spread of the data around the center is about 6 states. So this is our lesson today. How to classify the shape of the data distribution. Who has question now? Who has question?
No.
It's clear for all?
Yes.
طيب, what we learned today? What is the title of our lesson?
Shape of data distribution.
Great. So we want to remember what the meaning of symmetric and not symmetric. If the data on the left, the same data on the right, means we have symmetric shape. If we have the data on the right different than the data on the left, means we have not symmetric shape. When we have symmetric shape, just find the median to know the center, and when you have symmetric shape, just find the mean to know the center of the data distribution, then find the mean absolute deviation to find the spread. When you have not symmetric shape, just find the mean to know the center of the data distribution, then find the interquartile range to find the spread. This is our lesson today. So it's clear for all? Right. I want to remember you today, when you finish your schedule, please go to your account in Alif program.
Mister, can you
Yes.
remind me from which time to which time you can open Aleph?
From 12 a.m. to the 4 p.m. This is our lesson today, shape of data distributions. The number of our lesson 26. So please, I want to from all girls today to go inside your account in Alif program and to solve this lesson. And please send me your score to get a marks, to get a good marks, inshallah. Right. No questions?
Mister, can I make it tomorrow? This lesson?
Repeat, please.
Can I make this lesson in Aleph tomorrow?
What's your question?
Can I solve this lesson in Aleph tomorrow, not today?
Okay, no problem. And I want to remember you, don't forget, please. Don't forget, please, tomorrow we have exam at 10 p.m. o'clock. Okay? Now let us to take attendance. Today, Wednesday, the third period. Aliazia, absent. Becca.
Here.
Great. Rauda.
Mister, can I go?
Yes, you can. Rauda. Okay. Sarah Sultan. Absent. Selma. Absent. Aisha. Also absent. Fatima.
Yes.
Great, Fatima. Diane.
Yes. Bye, Mister.
Okay. Bye. Great. Thank you. So this is our lesson today. how to classify the sheep to determine the distribution and the spread in the data, to know the center and the spread in the distribution data. So I want to remember you, we have two cases, symmetric sheep and not symmetric sheep. When we have the data on the right, the same of the data on the left, means here we have symmetric sheep. So when you have symmetric sheep, just find the mean to know the center and find the mean absolute deviation to find the spread. And when you have not symmetric sheep, just here find the median to know the center and find the interquartile range to find the spread. And very important to know what the meaning of the gaps, cluster, outlier, and symmetric and not symmetric sheep, and what's the meaning of peak. So this is our lesson today. Thank you for your listening. Have a nice day and have a nice weekend. See you inshallah next week. Assalamu alaikum wa rahmatullahi wa barakatuh.